So in this video lecture we are going to see the DC-DC converter. So here we are going to see the different classifications and how it operates: buck boost and buck boost converter. So DC to DC converter, so here it will convert an unregulated DC input to a controlled DC output with a desired voltage level. It is very much needed nowadays as many industrial applications are dependent upon DC voltage source. The performance of these applications will be improved if we use a variable DC supply. So it will be able to improve the controllability of the equipments also. So examples of such applications are trolley buses, battery operated vehicles, etc. So here we have three DC to DC converter types. One is buck converter where V0 will be less than Vin, boost converter where V0 will be greater than Vin, and buck boost converter, it is a combination like V0 will be less than Vin or V0 will be greater than Vin. So it will take up either of the case. So first we'll see about the buck converter. It is a step down converter which is a DC to DC power converter which steps down voltage while stepping up current from its input to its output, that is from supply to the load. So this is the circuit for it, where you can see that there is a resistor which is connected to the V0 that will be acting as a load, and you have an input source, voltage source. Here it operates in two modes of operation. The first mode is mode 1, where the switch will be on, the diode will be off. So the voltage across the capacitance in steady state is equal to the output voltage. So the switch is on for a time t on and it is off for a time t off. So we can define the time period t to be t on plus t off, and the switching frequency as f is equal to 1 by t, which is also equal to chopping frequency. Second one is mode 2, which is switch is off but the diode is on. So in the earlier case you can see that the diode is not represented, so as the switch is connected. So in the second case the switch is open, so the diode gets connected. So here this is actually called mode 2. Here the energy stored in the inductor is released and it is ultimately dissipated in the load resistance, so which will help to maintain the flow of current through the load. Average load voltage is given by V0 is equal to T on by the total time period into Vs, so which is given as T on by T into V. So here you can say that the load voltage can be controlled by varying the duty cycle D. So T on by T is actually the duty cycle. So you can give the voltage, output voltage is equal to F into T on into Vs. So these are the output voltage and the current waveforms respectively. Coming to the boost converter. So boost converter, which will increase the input DC voltage to a specified DC output voltage. Step-up chopper works as a step-up transformer on DC current. In the circuit, a large inductor L is connected in series to the supply voltage. Capacitor will maintain the continuous output voltage to the load. So here also the diode prevents the flow of current from load to source. The input voltage source is connected to an inductor. The solid state device which operates as a switch is connected across the source. The second switch used is a diode. So the diode is connected to a capacitor and the load and the two are connected to in parallel as shown in the figure in the next slide. The inductor connected to input source leads to a constant input current, and thus the boost converter is seen as a constant current input source, and the load can be seen as a constant voltage source. So the controlled switch is turned on and off by using a pulse width modulation. So this is a block diagram. So you can see that at the source side you have an inductor, you have a diode, you have a load which is in parallel with the capacitor. So the boost converter, once again it operates in two modes of operation. The first mode is when the switch is on and conducting. So here the mode 1 switch is on and the diode is off. The switch is on and therefore it represents a short circuit, ideally offering zero resistance to the flow of current. So when the switch is on, all the current will flow through the switch, and back to the DC input source. Let us say the switch is on for a time t on and is off for a time t off. So we can define the total time period t is equal to t on plus t off. When the chopper is turned on, the current through the inductance L will increase from I1 to I2. As the chopper is on, the source voltage is applied. So this one shows you the mode 1 circuit diagram. So here we have the inductor current flow, you can see, and mode 2, here the switch is off, diode is on. So when the chopper is off, the KVL can be written as VL minus V0 plus Vs is equal to 0, or VL is equal to V0 minus Vs. So here VL is the voltage across the load L. Variation of source voltage Vs, source current Is, and load voltage V0 and load current I0 is sketched in the figure. Let us assume that the variation of the output current is linear. The energy input to inductor from the source during the time period, say on time t on, it will be given as Vs into I1 plus I2 by 2 into t on. During the time t off, the chopper will be off. So the energy gets released and the inductor to the load will be V0 minus Vs into I1 plus I2 by 2 into t off. So let us assume that the system is lossless. So I can equate V in is equal to V off, or they are equal. So this represents a mode 2 circuit diagram, and here what would be the output voltage. So as we have discussed, so you can equate the energies W in and W out. So you can equate the above expressions, and we can come to a conclusion that V0 will be equal to Vs into 1 by 1 minus t. So from this above equation, it can be seen that the average voltage across the load can be stepped up during the or varying the duty cycle. So we know that the D varies from 0 and 1, but as we can see from the equation above, that if D is equal to 1, then the ratio of output voltage to input voltage at steady state, it goes to infinity. So these are the boost converter waveforms. Next is the buck boost converter. Buck boost converter, this can operate as a DC-DC step down converter or a DC-DC step up converter, which depends upon the duty cycle. The input voltage source is connected to a solid state device. The second switch used is a diode. The diode is connected in reverse to the direction of power flow from the source to a capacitor and the load, and these two are connected in parallel as shown in the figure. Again, here the controlled switch is turned on and off by using a pulse width modulation. So this is a buck boost converter. This is a circuit diagram for it, and here also this operates in two modes. One is mode 1, which is switch is on and the diode is off. The switch is on and therefore represents a short circuit, ideally offering zero resistance to the flow of current. So when the switch is on, all the current will flow through the switch and the inductor and back to the DC input source. The inductor stores charge during the time the switch is on and when the solid state switch is off. Here the polarity of the inductor reverses so that current flows through the load and through the diode and back to the inductor. So the direction of current through the inductor remains the same. So this is the circuit diagram for the mode 1, and the second mode is switch is off and the diode is on. You can see that the switch is open. So in this mode, the polarity of the inductor is reversed and the energy stored in the inductor is released and it is ultimately dissipated in the load resistance. So which will help to maintain the flow of current in the same direction through the load and also step up the output voltage, as the inductor is now also acting as a source in conjunction with it. Thank you.